Hi there, this is Ms. Page. Welcome. This lesson is going to be about finding coterminal angles, specifically angles that are coterminal with our unit circle angles. Although the same procedure we're going to learn here can be used to find coterminal angles of all angles. So the definition of a coterminal angle is an angle that terminates in or has the same terminal side. So it terminates at the same place. So here we are seeing the positive angle of 257 degrees, which terminates here. And it has its initial side, of course, on our positive x-axis. And then we see the negative angle, negative 103 degrees here, with the same terminal side. So these two angles are what we call coterminal. We can also create an infinite number of coterminal angles by doing more than one revolution. So let's say I start here. Here's my 257. If I add another 360, I'm going to get another coterminal angle to 257 and negative 103 that has the measure of 257 plus 360 degrees, which would make it, looks like 617 degrees. We can also do the same thing in the negative direction. So if I head here, this is my negative 103, and then I head all the way around, come back to that same starting place. So that would be a negative 103 degrees plus a negative 360 degrees. And that would give us another angle of negative 460 degrees. We could just keep doing that, adding another positive or negative 360 and creating an infinite number of coterminal angles. All right, so let's take a look at these problems where we are going to be finding the angle in the first revolution. So we want to make sure we talk about that. Has to be coterminal with the given angle. So what do we mean by first revolution? When we talk about the first revolution, we're always talking about the first positive revolution. So the first full revolution in the positive direction. Here we're looking at angles that are given in radian measure. So that would be our interval from 0 radians to 2 pi radians. Though we would only include the 0 radians because 0 and 2 pi are themselves coterminal, so this becomes our default angle, 0 radians, for all angles in that same position. So here we're looking at our 5 pi halves. So one way that we can do this is we can look at our coefficient of pi, which would be 5 halves, and here we see it's an improper fraction, and it's equivalent to 2.5. So we know that it's bigger than 2 pi, and to get it into that first revolution, then we would subtract 2 pi radians, and 2.5 minus 2 is a half. So we get a half pi, which is what we call pi over 2 as a unit circle angle, and that would be then the angle in the first revolution that's coterminal with 5 pi halves. In the next problem, here we are looking at negative 5 pi thirds. So that would be negative 5 thirds pi, and negative 5 thirds is an improper fraction, and that would be the mixed number negative 1 and 2 thirds. When we have a negative number and we want to find the angle that's coterminal, we have to get it into that first revolution, which is positive, so we have to add full revolutions of 2 pi radians. So if we add our 2 pi radians to this, now I have to subtract, so I have 2 minus 1, which would be 1, and then from that 1 I subtract 2 thirds, and that 1 minus 2 thirds would leave me with 1 third, and so that's 1/3 pi, which is between 0 and 2. The 1/3 is between 0 and 2, and so that gives me my coterminal angle in the first revolution of pi thirds radians. So now looking at this third one, so we have 21 pi fourths here. And so that would be 21 fourths times pi. The 21 fourths improper fraction would be 5 1/4 times pi. And so here, now you could do this a couple of different ways. One is to realize that subtracting 2 pi, which is 1 full revolution, to get us into that first revolution of 0 to 2 pi radians wouldn't be enough, and to realize that you're actually going to have to subtract 2 full revolutions. So that you could subtract 4 pi all at once. If you don't realize that, that's okay, because you can subtract separately. So 5 1/4 minus 2 would be 3 1/4, and then you have to realize, oh, okay, that's still too big because 3 1/4 is bigger than 2. Subtract another 2 pi, and 3 1/4 minus 2 gives you 1 1/4 times pi. That's good because that 1 1/4 is between 0 and 2, so that gives us a coterminal angle of 5 pi fourths in our first revolution. As I said, you could also recognize that, oh, okay, well, if I just subtract 4 pi, which is 2 revolutions all at once, then I will get that 1 1/4, and that 1 1/4 is then my 5 pi fourths that way. A little bit faster, but not required to do it the second way. All right, let's take a look at a practice problem. So I want you here to pause your video and do this problem, and then start the video again and check your answer. All right, let's take a look at our answer here. So hopefully you came up with 7 pi 6. We're looking at our 19 pi 6, and this is done actually with a common denominator, and you might like that better, so this is worth talking about. So 2 pi has a denominator of 1, so the common denominator here of 6 and 1 would be 6, and multiplying by 6 over 6, that's where this 12 pi 6 came from. And then 19 pi minus 12 pi is 7 pi over the common denominator of 6. And that 7/6, which is 1 1/6, is between 0 and 2. So that tells us, yep, we are in the first revolution. Or you can just look at it as 3 1/6 pi minus 2 pi, which would be 1 1/6 pi, which is your 7 pi 6. Let's try another one. Pause your video here. All right, let's check our answer here. So here are negative 17 pi fourths. This one again is done with our common denominator method. And so again, 2 pi has a denominator of 1, and 4 and 1 have a lowest common denominator of 4. So we'll multiply this by 4 over 4, and that gives us this 8 pi fourths. We have to remember that 17 is negative, negative 17 and 8 is negative 9. Then you have to realize, okay, you're still negative, so you got to add another 2 pi to it, which is your 8 pi fourths, and that gives you a negative pi fourth. So this is still negative because that's a negative 1/4. Still not in that first revolution. So we have to do it a third time. And now finally we're at 7/4, which is 1 3/4 pi. That's between 0 and 2, so that becomes our coterminal angle. You could also do it as negative 17 pi fourths, so that negative 17 fourths is negative 4 1/4 pi, and realize, oh, okay, well, I could add 4 pi, but that would still make it negative, so I have to actually add 6 pi. And 6 minus 4 would give me 2. And then I have to, from that 2, also subtract this 1/4. And 2 minus 1/4 would be 1 3/4 times your pi, and 1 3/4 is your 7/4. All right, now we're going to take a look at these problems, which are in degrees. So primarily we focus on radian measure because that is what we will you focus on, and primarily with calculus problems. But degrees do come up, so we want to be comfortable with working with degrees here too. So our negative 580 degrees, we would need to realize, okay, our first revolution here for degrees would be from 0 degrees to 360 degrees. And again, 0 degrees and 360 degrees are coterminal with each other, so the 0 degrees becomes our default angle for angles coterminal with these. And so our negative 580, we could add 360, and it is not going to become positive. So you could add multiples of 360 just like you add multiples of 2 pi if you're comfortable with that. If you blow it though and you accidentally add a number that's not a true multiple of 360, then you're not going to get the right angle. So just consider that, because these again are no calculator problems. So I'd be looking at, okay, I'm going to have to subtract these two, and that's going to give me 220, but it's going to be negative because of the 580 being larger. So then I'm going to have to add another 360. So here again, I'm going to have to subtract 360 minus 220, and that gives me 140, and this time it will be positive. So here's my coterminal angle in the first revolution. For 600 degrees, all I need to do is subtract 360, and you may or may not realize that as you're starting, but this is going to give us 240 degrees, and that is between 0 and 360. So there is our coterminal angle. All right, let's take a look at a practice problem. So pause your video here, give this problem a try. All right, let's take a look at the answer here. So on this one, you either have to subtract 360 twice, because the first time you subtract it, you're not in the first revolution yet, not quite. So you have, or you might have realized that 2 times 360 is 720, and that way then you can do it in one step. Just be careful. Make sure that if you're doing 2 revolutions in degrees, you remember it's 720. All right. Now, we're going to take a look at this type of problem, which is drawing an angle in standard position. We did this in our first lesson, but now we're looking at angles that are outside of the first positive revolution and negative revolution, coterminal with our unit circle angles again. So one of the things that I want to know is where my angle here of 480 degrees terminates in, or what it's which basically means I need its coterminal angle in the first revolution. So the first thing I'm going to do is find the coterminal angle. So I have my 480 degrees minus 360 degrees, and that gives me 120 degrees. So 480 and 120 are coterminal with each other. 120 is a multiple of 30, so we talked about the strategy of dividing quadrants into 3 equal pieces, which would represent 30 degrees each, since a quadrant is 90 degrees. And so I know 120 is in my second quadrant, but if you're not sure, you can of course do all of your guidelines. So this would be our 30 degrees. So we have 30, this would be 60, this would be 90, so here's our 120. So here's where our angle is going to terminate. It's right here. And of course we have to draw a ray for its initial side. Now here's what is different. We talked about needing an arc that starts at the initial side, goes in the correct direction, which here would be counterclockwise for the positive direction. But we can't just draw an arc to the terminal side, because that would only represent 120 degrees, and we're actually supposed to be drawing 480 degrees. So we have to realize that we have to go our initial 360, that 360 and 120 together add up to 480. So here's my 360 degrees, and then the extra 120 now gives me that angle total of 480 degrees. All right, let's take a look at this one. So now we're in radian measure, but basically the procedure is the same. We want to know what is first coterminal in our first revolution, so we know where it terminates. So our negative 29 6 times pi, this improper fraction as a mixed number is going to be negative 4 and 5/6. So we're going to have to add multiples of 2 pi. Adding 4 pi would not quite be enough. We'd still have negative 5/6 left over, so I'm going to add 6 pi. Just do it in one step. So my 6 minus 4 would be 2. And then from that 2, I also have to subtract the 5/6. And 2 minus 5/6 would be 1 1/6. And 1 1/6 pi would then be 7 pi over 6. So you might recall that your 30 degrees is your pi 6 radians. So again, this is a multiple of 30 degrees or pi 6 radians. So again, I can divide into my thirds. Now I know, because I'm perhaps more familiar with the unit circle at this point than you are, that this terminates, my 7 pi 6 terminates in my third quadrant, because 6 pi 6 is pi, and that's this right here. So this is my pi 6, 2 pi 6, 3, 4, 5, 6 pi 6. This is my 7 pi 6. And so that's where this angle is going to terminate. So This is my terminating side, my initial side. Now, when I draw my arc to represent my angle again, I have to make sure my arc represents my original angle, which is negative, and that means that my arc needs to go in the clockwise direction. But here's where it's a little trickier to do the arc correctly. It's not about the 6 pi for a negative angle. It's about this negative mixed number pi. The negative 4 pi is 2 full revolutions in the negative direction, and then the 5/6 pi is the extra part. So I start here, go in the negative direction. Here's, oops, that was not what I was expecting it to do. Let's try that again. There's negative 2 pi. There's negative 4 pi. And then here's our negative 5/6 pi to give us a total of negative 29 pi 6. All right, there's a practice problem for you to try. Here you go. Pause the video. Draw this angle. All right, let's take a look at the results here. Whoops. There we go. So here what we're looking at is our 7 pi thirds, which is 2 1/3 pi, minus the 2 pi would be pi thirds. And that, if you remember, with the denominator of 3 is equivalent to 60 degrees. So our terminal side is here, where it would be 60 degrees. But then our arc, notice, has to go the 2 pi plus another third. So it goes all the way around. That's our 2 pi in the positive direction plus another pi thirds to get to our 7 pi thirds angle arc. All right, that's the last problem in this lesson. Give your assignment a try and have a great day.